right, good morning. I'm Frank Gromolowski. I'm the Executive Director of the NYU Entrepreneurial Institute and am thrilled and honored to have Dr. Bob Langer with us today as part of our BioVenture speaker series. Bob is the David H. Koch Institute Professor in the Department of Chemical Engineering at MIT. He has written over 1,300 articles with over 1,080 patents worldwide to his name, which have been licensed or sub-licensed to over 300 pharmaceutical, chemical, biotechnology, and medical device companies. He is the most cited engineer in history with more than 163,000 citations. In recognition of his work, Dr. Langer has won virtually every major engineering and technology prize in the world. At 43, he became the youngest person ever elected to all 3 American Science Academies. He is one of the 4 living individuals to have received both the U.S. National Medal of Science and the U.S. National Medal of Technology Innovation, and that's just the beginning. The list goes on, and it's far too long to read here, though I'd like to point out that this year, Dr. Langer added the prestigious Queen Elizabeth Prize for Engineering to that list, and as part of that, the prize committee estimated that he has improved at least 2 billion lives through his discoveries that have spanned treatments for cancer, diabetes, heart disease, schizophrenia, and even the dreaded curse for frizzy hair. He received his bachelor's degree from Cornell and his Doctor of Science degree from MIT in chemical engineering, and received honorary doctorates, if I'm counting correctly, from 24 universities across 5 continents. He has been called the father of innovation, a modern-day Thomas Edison, and a serial entrepreneur, having spun out more than 30 companies based on research that originated in his lab. And that's why I'm personally so excited that he is here to join us today. So please give me a warm welcome and
Thank you. Thank you.
to Bob.
Thank you.
So before I ask you any questions, I just love to just get a sense of who here is in the room. So who here is a faculty member within the university? Okay, a postdoc, a graduate student. Okay, and what schools do we have represented? The medical school or medical center? Dentistry, nursing, arts and science, Courant, engineering. Who am I forgetting? I'm sorry? Steinhardt. I'm sorry? Business. Stern. All right. SPS. Okay. We have a great cross-section of the university. One last question. Who here is working on some research that they have an interest in commercializing? Okay. A good number of you. All right. So that's who's here.
That's great.
I told him a little bit about you, but I'd like to know a lot more. So I guess first off, tell us about your lab at MIT, just to kind of put it in context in terms of your research budget, the number of students, postdocs, projects, et cetera.
Sure. So, well, thank you. It's very nice to be here. Our lab, so we have a pretty big and interdisciplinary lab at MIT. It wasn't always that way, but I'd say we probably have 150 people. I would imagine roughly 75 or so have PhDs or MDs. There's technicians, there's graduate students, there's undergraduates. Budget, I think, is probably in the order of about $18 million a year. And the projects are diverse, but they're almost all at the interface of material science and engineering on the one hand and medicine on the other. But they're fairly basic in the sense that sometimes we create new materials, and those materials can be used for anything. I mean, a lot of our aims are things like maybe new kinds of gene therapy or new kinds of drug delivery systems, but again, when you create new materials, they can be used for anything, and that includes even frizzy hair sometimes. But yeah, and it's I like to think a very collegial lab and kind of almost like an ideas factory. I really want to encourage people to come up with ideas and to be leaders. They could end up going into faculty positions or companies, and they do both. I mean, I think we've had something like 700 or 800 people leave the lab. Close to 300 are now professors all over the world. And many have started companies, have become CEOs or have other positions at startup companies, and others have gone into larger companies or government positions and just about everything.
So I use the term to apply to you of being an entrepreneur. Is that a term that resonates with you? And if so, how did you go from being a grad student, postdoc, to where you are now as really a prolific entrepreneur?
Yeah, it does resonate with me today, but it wasn't how I thought about myself a long time ago. You know, when I was a graduate student, this will be a little bit of a long answer, but maybe give some sense of why I've done some of these things. So when I was a graduate student, I was chemical engineer, and when I got done, all my friends went into the oil industry. And I thought, you know, at 25 years old, I should do what my friends do. But when I went for my job interviews, I wasn't very excited about those positions because I didn't see myself making that much of an impact. Like people would tell me, if you could just increase the yield by 0.1% of a chemical, how wonderful that would be. And I didn't think it was that exciting. Nonetheless, I got 20, they had so many job openings, I got 20 job offers from oil companies, like 4 from Exxon alone. But I decided I wasn't going to do that. I looked into education jobs, like I was very interested in developing new chemistry curricula and things like that. I'd help start a high school for poor kids. But nobody actually would hire me for that. So then I thought about medicine, and actually nobody would hire me for that either, except one guy, actually. I remember one of the people in my lab said, there's this guy named Judah Folkman, who was a surgeon in Boston. He said, sometimes he hires unusual people. And he hired me to work on this project to see if we could find substances that could stop blood vessels from growing. And so I worked on that. And I also, in the course of that, created new plastics that could deliver molecules of a large size for the first time. Well, you know, and when I did that work, people were very skeptical about it. It was very much criticized initially, and I got off to a rocky start in my career. But nonetheless, over time, people started beginning to use it. But still, they were using it academically. So it must have been for about 10 years, you know, I'd be publishing papers, and nobody would use them, other than other academicians. But I wanted the world to use them. I thought it was important. So then finally, after about 10 years, a couple of very large companies like Eli Lilly and others licensed them and asked me to be a consultant, gave me a consulting fee and a big research grant for a young professor, and they were going to work on it themselves. But what happened was I went from like a Ford Pinto to a baby Mercedes. I mean, that was good, you know, because I got the consulting fee. But they didn't do much. You know, they'd do an experiment or two, and they'd give up. And so what happened was it went nowhere. But then about a year after that, there was a company in Baltimore that came to see me. They'd read about some of what we did, and they said, well, they had raised some money. They didn't know what to do with it. But they said, well, can we license something of yours? And I said, what? And they said, well, you know, whatever you want. And so I was really amazed. I said, okay, well, we created this new polymer. How about if you give us funding for developing that? And we're doing this collaboration with my friend who had just started as an assistant professor at Johns Hopkins, Henry Brem, and said, well, maybe you could give him funding to develop it for trying to treat cancer. So that was, this company, in contrast to Eli Lilly, had 50 people, but they would work day and night on our project. It was this tiny company. And ultimately, that led to a new treatment for brain cancer, Gliadel. And I realized then that these tiny companies would live or die based on our inventions, whereas these large companies, they didn't have the same attitude. And so then the next year, one of my friends, Alex Klebanoff at MIT, said, Bob, we should start a company ourselves. And I thought to myself, yeah, you know, that's probably a good idea, because I could see I had other things in the lab that I wanted to develop, and I could see that these little companies really could make things happen. And also there were students in my lab who were interested in working at them because they had spent years of their life working in the lab on these very things. And they wanted to see their work go out and help the world. So I tried that. That was a little company called Enzatech, which is now Alkermes, and it worked out pretty well. And so we just kept doing it, and so and to me, it's been a wonderful vehicle for taking academic discoveries that we make, and bringing them forth to the public. So so now I do think about myself that way. But like I say, it didn't start like that.
And you're hooked.
Well, it's not just that. It's that I feel that it's just a good thing, and then I think it's also because it creates products, it creates jobs, it can create new medical treatments that can help people, and also I think as an educator, as a professor, it's been wonderful for my students. I mean that they can go out, and I've had, like I say, students work at these startups, become CEOs, create new products, and I think that's just a wonderful career option for them. So I think it has many, many great benefits. Not to say that there's not ups and downs, but overall, it's just been a very good thing.
So I want to come back to your students, but you often see in articles, sometimes even in interviews with you, there's unnamed sources that say commercialization is the work of the devil from an academic point of view, and that science should be purely for the purpose of advancing knowledge. So, do you hear that? Do people say that to your face? And if so, what do you say to that, or what do you say to them?
Well, people did say that to me in the beginning, and I certainly was criticized for that too. I guess I say a couple things. One, I mean, I don't agree with it. I think that science is it is for knowledge, but I also feel, why would we not want it to do good to help people? I also feel when people make that comment to me personally about that or patents, I guess one way I answer them is, people might say I have a lot of patents, but actually I have a lot of papers too. I have more papers than I think I have way more citations than any other engineer, probably almost anybody in history. So
1,300 papers.
Yeah, but also if people follow
your
this,
poor keyboard.
Yeah, but if people follow this, there's something, and this has nothing to do with patents. There's something called an H-index, which is often a reference that people look at for how widely cited you are. And mine's 217, which is, I mean, that's extremely high. So the point is that
I think mine's 0.
Well, but you're in a different area. You're in a different area. But I guess my point about that is that we are disseminating knowledge too. I mean that we wouldn't have all those citations unless people were that we are putting these things out there for people to work on. And so I feel like that those things, in a way, for me, have gone hand in hand. In other words, we publish everything we do so the whole world can use them, but we patent them too, because I think that also provides an incentive for investors and venture capitalists to want to put money into these things so that we can get them out to the world.
So would it be right to paraphrase that the commercialization or the commercial application is actually the public interest or part of the public interest in that regard?
I think so, because these are things that can save people's lives or improve people's lives or make them happier.
Fix their hair.
Well, that makes a lot of people happy. So, so absolutely. So my feeling is that I think it is, and they create new jobs. I mean, I see very little downside to it.
Now, another argument, though, is that it skews the interests of the research. Do you see that? How do you balance that?
Yeah, I don't.
Is there a tension there?
There could be, but I don't feel that there is. At least not the way we do it. In other words, we work. I mean, again, just to pick some examples from our lab, we work in fairly basic engineering and chemistry areas, and we publish stuff that's fairly basic. And again, just to pick an example. Again, from publications, so the really top general journals are places like, say, Science and Nature. So last year, our lab had 13 papers in Science and Nature. This month, we've had 5 papers in Nature alone.
Wow.
But Nature journals, I should say, like Nature Biotech or Nature Medicine or Nature itself. But the point is that we publish everything, and we really try to solve these problems that I feel can be very important. And I'm never willing to sacrifice. I think that's very important for the students to have those papers. I think it's very important that the world see them if they want us, if people want to use them for different things. So I think sometimes there are people who complain about it, and every so often, sometimes people do what you say. But that's not what we do. I mean, my model has been to publish everything, publish everything in absolutely the top places if we can. But I don't want it to stop at a publication. I mean, I want it to go and as far as it can to help the world. And so we try to do that if we can. Not always able to.
So on a slightly different but related point, the diversity of research and products that have come out of your lab is impressive, if not amazingly diverse. What do all these things have in common, and how do you come to understand, or how are you informed that these are interesting problems worth tackling?
Yeah, well, I kind of break that down into two parts. I mean, sometimes, like, we just come up with ideas. Like I've had an idea about like a drug delivery microchip, for example, or a controlled release of all kinds of like large molecules many years ago. And I should say that when we first did some of these things, it's not like I had a specific application in mind. I just thought if we could invent something or discover some principles, that it would open up all kinds of possibilities. But I didn't necessarily know which ones would be the best possibilities. In fact, if I were to look back at what I thought might have been, I would have been wrong. But I still felt that they were big principles. And what would happen was, and that's another good thing about starting the companies, is it's a team effort. So in the MIT lab, we do the more basic work. When we start a company, a lot of business people are involved, which I'm really not. I mean, and they work with the scientists to figure out, well, what is the best application for some of these things? And they may do a lot of analysis to try to figure out, the markets, the regulatory issues, the freedom to operate on patents, and take it far beyond what we do. So to me, it's like a team effort to try to sometimes figure out what it is that, we should be doing with these different inventions or discoveries.
So I read maybe on that thread that someone once described your lab as porous. And I think that kind of talks to them. I think they're talking to the multidisciplinary nature of the people in your lab and the interfaces you have with the outside. But can you explain maybe in a little bit more detail how that works in practice? How do you nurture that and sustain that?
Yeah. So I think, well, what we do in the lab is I run a pretty loose operation in the sense that, it's not my goal to tell people what to do. It's my goal to get them excited about science, to get them talking to each other, to let them think and realize that almost anything is possible in research, and to try and also to try to create an interdisciplinary environment where people are going to learn from each other. But it's also, I think, well open to things like industrialization if people want to. So a number of my students now today are venture capitalists, and they know other students in the lab. I mean, so there's a whole network that people, current and former students, can avail themselves if they want to, and it's fairly informal. I've
Langer Lab alumni.
Yeah, and it's a pretty big alumni. So and we've often had, like, sometimes, when I have younger students, they're not sure. I think, in fact, one of the most challenging things if somebody's an undergraduate or a graduate student is, what are they going to do with their life? What's their career going to be? So I've often had older students come in and who have different career paths and give lectures to the younger students, and I think that's been helpful. But I think the porous, I'm not sure exactly who said that, but I think it's that there's just a lot of flow through, in terms of ideas and people.
So do you actively bring them in? It sounds like. Do you also kind of push people out of the lab to go out and learn what's going on outside the lab?
I think I actually don't know that I do that. I think they'll probably do that anyhow. I just really want people to have a good experience. And so and I don't think there's a single formula for that. So to me, I just want to see the students have the best experience possible. If they find things inside, that's fine. Outside, that's fine. It's like I kind of view that I'm sort of being a guide, but they will figure out, on their own volition, exactly the directions to go.
So of your students and postdocs, do you have stats on kind of where they've gone between academia, industry, startups?
We have some stats. Like I say, I think about 300 are professors now around the world. A lot go to startups. But a lot go to big companies too. So they're everywhere. I would think it'd be probably fairly evenly distributed. But people have really, I think, enjoyed the Cambridge environment. So they come to MIT, and if there are startups, sometimes that's been a very popular path for people to do. And then some of our students have started those startups. So that's then they hire others. So it's been a pretty good network.
So incestuous in the good sense of the word.
I like to think that, yeah, and I think it is. I think that there's just a good camaraderie and relationships between the people.
So shifting gears a little bit. So how many projects do you have in your lab at any point in time, roughly?
Yeah, that's a tough question only because I could say anywhere from 2 to 50. Most of what we do is either what I'll put in the area of drug delivery or tissue engineering. But when I come to drug delivery, there are maybe 15 or 20 drug delivery projects, like nanotechnology kinds of projects might be one, gene therapy might be one. We've created these implantable microchips that you can deliver drugs by remote control. We're working on pills that you could swallow that could last up to a year. We're working on delivery systems for nutrients and vitamins for the third world. And then on tissue engineering, we're doing everything from basic ideas of taking plastics and seeing how stem cells grow to more applied things like can we help people who have hearing loss or are paralyzed or things like that.
So
treating diabetes.
So when you're looking at that portfolio, how do you know or how do you assess when a project is ready for prime time in the sense of when there's a commercial path worth pursuing and maybe to form a startup and then what happens?
Yeah, well, I guess I usually have about 4 or 5 criteria. One is that it be what I'll call a platform technology. A platform technology could be something like genetic engineering or gene editing or a drug delivery system, meaning that you could apply that technology to 50 or 100 or 1,000 different molecules, in contrast to a single product, which might be like a stent or something like that, just a device. And the reason for that is that, one, I think both myself and I'd say MIT too, you want to maximize the value of your technology. So if I license the platform technology to Merck, nothing against Merck, but Merck would use it for their drugs, right? So it would never be used for Pfizer's drugs or Lilly's drugs or anybody else's drugs. Whereas if I had a little company, they could work with Merck on their drugs, Pfizer on their drugs, AstraZeneca on their drugs, and we do. So that's the first thing, is that you have a platform technology. Second thing is I want to make sure that we have a really good paper that I feel is game-changing. Probably a paper that we could publish in Science or Nature and hopefully have. Third, I'd like to have a really powerful patent backing it up. I don't think if I don't have that, I'm not sure that the investors will put a lot of money in. Fourth, especially in the medical area, you really want to be reasonably advanced. Everything in medicine, I mean, if you're doing things on the internet, it doesn't take so long to get a proof of principle. If you're doing something in medicine, it takes enormous amount of time. So I'd, at minimum, like to have good animal data, to reduce the risk. And that's very important because, first, if you don't have it, I think it's going to be hard to get the investors to give money. But even if the investors do give money, the problem is the window to exits for those investors may take a really long time, and they'll get tired, and it just, in my experience, makes things difficult. So you'd like to have that. And fifth, like I say, a lot of times I've done it because my students or postdocs in the lab or friends want to do it. And so that, I think that's really important, not just because I feel a responsibility, and I do, to want to make sure that they have good experience not only while they're in the lab, but after. But the other thing that I've noticed as an enormous side benefit of companies being successful is what I'd call the champions effect. That is, that I think companies are going to be much more successful when the people who work in them are willing to walk through walls to get their ideas out to the world, rather than just handing it off to some professional with a lot of experience. I mean, to me, the classic example of that's not us, but Steve Jobs and Apple. And people may know that story, but I'll just tell it in case they don't. When Steve Jobs and Steve Wozniak started Apple, I mean, they had no experience, but they started, got off to a pretty good start. But then their board decided that they didn't have enough experience, so they needed to hire a more professional CEO. So they went out and hired the president of Pepsi, and they fired Steve Jobs. And for the next 15 years, they went through one professional CEO after the other, and Apple.
I was there for 3 of them.
Is that right? Wow. So you could tell the story better than I. But then he came back and obviously did pretty good. And I think I see the same thing with these biotech companies and the other things that we do. When we have our students there who spent 4, 5, 6, 7 years of their life doing something, their passion for walking through these walls and getting things to work is very, very high. And it's not to say that the other people are bad people, but they don't have the same investment, and I think that makes a big difference.
So can you maybe give us an example? Is there an archetype of that grad student or postdoc of yours, and what the process looked like and the role they take and how it got started?
Yeah, I'll give you actually a recent one, which I'm excited about. So I had this graduate student, Armin Shari. He was an undergrad at Stanford, and did his thesis with me and Klaus Jensen, who was then our department head. And while he was doing it, he was doing these experiments on cells. And he did this experiment one day where he would actually squeeze the cell and notice that things would get into it. So we studied it more, and he created this, what we call microfluidic platform, squeezed the cell, and we noticed that you could put genes into it. And he studied it and actually did his whole thesis on it. We published an important paper on this in 2013. He originally thought he was going to be a postdoc and go into academics. But he'd come and talk to me from time to time. And he said, well, Bob, what should I do with my life? And my answer to students always is follow your passion. Don't do something for money. Don't do something because your parents tell you. I mean, and believe me, I'm sure you see the same thing. A lot of students will do that. And so even though he was doing a postdoc and he was looking to be an academic track, and he was good, he decided, we did start this little company with one of his friends actually being CEO.
Who was it called?
Squeeze, SQZ. And we were sort of selling reagents, and it was doing okay. I mean, again, this company's only 2.5 years old, but at any rate, we... But then, I'd keep talking more to him, and he decided, I should leave this postdoc and I should run this company because I really care about this, and I really want to make my life about that, about, taking his PhD invention and getting it out to the world. So he became the CEO, and we were very fortunate that Polaris, which is one of the venture groups I work with, there was a woman, Amy Schulman, and she's like brilliant. She was chief counsel at Pfizer, ran a huge division for it, but decided to leave Pfizer, and I talked to her, and she joined a venture capital fund that I work with a lot, Polaris, and I introduced her to Armand, the student, and she said she'd have enough time to become an executive chairperson and kind of almost be like a coach to him, and she's been great. So at any rate, just a couple things on that. In 2014, Scientific American came out with their 10 most important breakthroughs of the year. Number 1 was CRISPR, which is the gene editing approach. This was number 2, which was nice. About 3 months ago, Armin and Amy inked this deal for $500 million with Huffman LaRoche to change a certain type of immune cell by this squeezing technique. And now we have probably about 30 people, and so there's a reasonable amount of money. We'll probably go raise some more money, but the goal is to use this for all kinds of things. But and he's hired some other students from the lab.
Now, is that typical in your experience that they go on to be a CEO, or?
Probably CEO is high, but I'll just give a second example, which is also recent. I mean, I could give tons, but this one is also good. Also involves that woman Amy that I mentioned. So Bill Gates has given us money to help things in the third world, and one of the things I mentioned that we're working. One of the biggest problems in the third world is patient compliance. It's not very good in our world either, but people, even if you're supposed to take a drug, they don't. I mean, like just to give you an example, Denny Ausiellos, who's a friend of mine, he was chief of medicine at Mass General, said to me, Bob, he said, what do you think is the mean amount of time somebody takes a statin drug? If you have heart disease, people tell you to take a statin for the rest of your life. So I could give you all a quiz. I don't know what people think it is. Any ideas? That's very close, 3 months. And in the third world, all these numbers are much worse. The World Health Organization says the biggest problem is not new drugs, it's just getting people to take their drugs. One big problem, just to give you an example, the Gates Foundation's calculated, is if you could get people in the third world to take ivermectin, a pill every day for 2 weeks, and keep the blood level over 6 nanograms per mil, you could wipe out malaria, which has been a huge problem there. So, but they don't do it. So one of the things that Bill Gates talked to me about, and some of his colleagues, is could we make a pill that you could swallow once and last, say, for 2 weeks or a month, because they'd get it when they go to their doctor's office. So I had got another postdoc in my lab, Gio Traverso, who is an MD and a gastroenterologist, and we had a lot of people. Gates gave us a lot of money for this, so we had maybe 20 people working on it. And one of them was another MD, Andrew Bellinger from Mass General. And so anyhow, we made a lot of progress on this, published the first paper, again, following the model I said in Nature Materials last July. And so we just started a little company on that with Amy as the CEO about 6 months ago. And the first 3 employees were people who worked on that project in the lab. So she's the CEO, but Andrew Bellinger, who's the MD, is like the chief medical officer, and I have another guy from my lab who's a Rhodes Scholar who's working there, and another graduate student, and she's working there. And I mean, that's basically the company, but now we're going to go and probably raise about $20 or $30 million. There's a number of people who want to put money into that. It's, again, sort of a paradigm shift, because you could have for pharmaceutical companies, you could take pills that could last, super long times. But those are pretty typical.
So is it typical that, so I think the number I referenced was over 30 startups. Are pretty much your grad students and postdocs in almost every one of those?
Yes. Yes.
Okay, so that's interesting. And what's your role in that once it becomes a company? I mean, I don't think you've left MIT.
No, and I won't. I love MIT and I love doing this. Well, my role is usually being on the board of directors, maybe being on the scientific advisory board. It's not that I always want to be on the board of directors, but the investors usually want me to be on the board of directors.
Why is that?
I think they think that it helps them raise more money. I mean, if you're, sadly, it's like you'd like to think that when you're a scientist that your greatest value is science. But I think a lot of times when you're involved in companies, one of the things you end up spending a lot of time doing is raising money. And so being involved in that process is something I think that they want, because really, especially in the medical area, to create a successful company, it very often involves raising hundreds of millions of dollars.
So
maybe billions.
So I think that's really interesting, the point of there's almost always one of your folks involved. So what determines those projects? Is that what determines those projects that go on to become a startup versus those that you license to, a Pfizer or Merck? Or how is that decision made about what's licensed versus what becomes a company?
Well, that is one of the things. It really goes to those 5 or 6 criteria I mentioned earlier. That is one of the things. But I would be leery of licensing something that was a platform technology to any one company, because I don't think it'll have maximum utility. Okay. But certainly having, whether we're really going to start a company or not, which is a huge effort, I'd want to meet all those criteria that I mentioned, because it's a long, hard process in my experience.
Now, I've also read or heard somewhere that one of the things that people have credited to your success is that actually you patent earlier in the process than many do. And I don't know if that's a Bob Langer thing or an MIT thing.
It's probably both.
So talk to that. Why is that, and why do you do it, and why has it been important?
Well, patents, the thing is especially in the medical area, if you don't have a patent, I don't think you're going to get significant investment. Investors know they're intelligent investors, which many venture capitalists are. They'll know that it'll take tens, maybe hundreds of millions of dollars to get profitability, and they also know that they'll probably be doing deals with the Pfizers and the Mercks of the world. And if you don't have good patents, then all that investment, then anybody can do it, and so they'll feel that the patents are key. So to me, having really great intellectual property is absolutely critical. I think MIT and Stanford and places like that realize that too. I mean, you only have to look around those areas to see what's happened, and in terms of companies starting up and being successful. So I think that making a premium on really good intellectual property, having really what I'll call good patent claims, that's been a key thing. And it's not necessarily patenting early, it could be. I certainly don't want to patent late and lose the opportunity for the broadest possible claims. But generally what I might do is when we're ready to submit a paper, I never want to hold up that paper for any reason at all. So I certainly want to make sure that the patents are, I might use a draft of that paper as a basis for a patent or an very early version of it.
You talked a lot about venture capital funding as it relates to your startups. Do you also pursue non-dilutive sources of funding? I mean, obviously, I imagine the NIH and NSF and others fund a lot of the research in your lab.
Yeah.
But when you first, are ready to create an entity, is it like venture capital on day one, or are you looking at SBIR and STTR or other kinds of programs? How's that played into?
Well, we do look for non-dilutive funding, but my experience, and some of the companies that I've been involved in have done a really good job of getting non-dilutive funding. But I find that most companies that I've been involved in, venture capital has still been very important because you can't get, unfortunately, again, in the medical area, it just takes so much money. And I don't think you can get that kind of money for most of the things that we've been involved with from government grants. So that's why, you just need more.
But do you use that non-dilutive funding though to kind of kickstart it, so to speak, and then bring in the venture capital, or?
Probably not. I probably get the venture. I mean, there have probably been examples when we have, but for the most part, we've probably used venture capital. Sometimes not huge amounts of venture capital, but but generally we've used some type of investment vehicle, just because then people are committed to putting more in, and you're going to need it. That's not to say you can't use other models, but it's just what we end up doing is usually pretty expensive.
So how I know you referenced Polaris, and I know some of the folks there, and you definitely have a special relationship with them. But how did that come into being?
Yeah, well, I have there's 4 maybe venture capitalists in the Boston area that I work with a lot. They probably the most, but also Flagship and Third Rock and PureTech. But Polaris in particular is because there's a guy named Terry McGuire, and he's he invested early on in a company, and I think we developed a very good working relationship, and he treats all our students very, very well, and everybody at these companies very well, which means a lot. Not everybody does treat founders and employees well, and he's.
So what does that mean, though, to treat them well?
Yeah, that's a great. Yeah, I'm glad you asked that. What I mean by that is, when the business world to me is very different than the academic world. Academic world, I think, what people are most concerned about is, reputation and things like that. I think in the business world, big concern is money, and if you're a venture capitalist, you have a responsibility to the people who've invested in you to get the best possible return. But also, when you create a company, the pie is only so big. And if you decide that you're going to take 99% for yourself and give everybody else 1%, well, that's, maybe you'll create a great company, but you might not have a lot of happy people. And I think it's been very important to him that I'm exaggerating, obviously, but I think it's been very important to him to have happy people with the idea, the added benefit that they'll come back to him with their next idea and their next idea, and so I think that means a lot that he's willing to do that.
Well, I think that also ties in nicely to your notion earlier, people wanting to walk through walls. If they're not happy and they're not motivated,
I agree.
That's the way to make sure they get demotivated.
I think that's very well said on your part. I agree.
So I think I know the answer to this, but you've received a ton of accolades and I think extraordinary success by any measure as an academic and as a scientist and an entrepreneur. But what do you, in your mind, what has been your greatest accomplishment?
Well, I always say my students, I mean, I feel like for however anybody wants to look at it, I feel my students, if I looked at any professor, I think I have like 15 students in the National Academy of Engineering, 10 in the National Academy of Medicine. Many have gone on to be great CEOs. I mean, deans, all kinds of presidents of universities. So I feel when I look at how well they've done, that's the thing that I'm probably proudest of.
Because I've also heard I don't know if they were your words or someone else attributed, that you treat your students like they're your extended family.
Well, I feel that, I feel that too. I mean, obviously your family is what you're closest to, but I do feel like you get, and I'm sure people here do too, you're a professor, you see your students do well. I mean, it makes you feel really good, I mean, and if they don't do so well, it makes you feel bad. I mean, I think, you have a big investment in them, and I love seeing, my students get a great job or get a paper accepted in a great journal, or, all that means a great deal to me.
Now, with that many, how do you keep in touch with that many of them? It's kind of staggering to think about.
Well, they're pretty good at it themselves. We have, I think all kinds of ways. I mean, we've had, again, the ones in the lab, we have like meetings and, get-togethers. I have a, lab meeting once a week with everybody. We have a beach party and pizza meetings, so forth, and we have sort of what we often call subgroup meetings. But with the alumni, I mean, people are pretty good about keeping in touch with me. We have a conference in Hawaii every so often, and a lot of them come to that, and they've had
like a Langer Lab alumni.
Well, it's not just that, but there's a lot of people that come, and there's other meetings, and they're very close to each other. I think it's it's just been wonderful to see that.
Is that something that you learned from someone else? Are you recreating an environment that you had as a grad student anyway, or is this
definitely not as a grad student, but as a postdoc? Well, the person I think that influenced me the most as an educator was my postdoctoral advisor, the man I mentioned, Judah Folkman, and not in all the ways we're talking about, but in a couple of very important ways. I mean, the great thing about Judah Folkman was, I don't know if people know his career, but it was pretty amazing. I mean, he had this idea that if you could stop blood vessels from growing, you could stop cancer. And that led and has led to many new cancer treatments and treatments for blindness and so forth. But there are a couple very good things that I did learn from him, more by just watching. I mean, one was that, he believed anything was possible. And seeing that as an example was great for me. And the other thing he did, which I thought was also really good, and again, it's not necessarily intentional, it's just part of his personality, and maybe it's part of mine, is what I'd call positive reinforcement. In other words, people, a lot of times I know people have asked me as a professor, well, this student's not working hard enough, or that student's not working hard enough, and should I tell them that they need to work harder? And I never do that. I think what I want is people to work hard because they want to, because they really believe in what they're doing, but not because somebody tells them to. I don't think that works. And so I think he was just a great role model in terms of those kinds of areas. And I think the rest, to me, of the things I do probably follow from examples like that.
So if you have a student or postdoc or someone in your lab who's maybe not performed to their level, are you suggesting that you try to find the thing that they're doing well and encourage that behavior rather than discouraging the bad behavior?
Well, if they're doing something bad, I don't want them to keep doing it. But but in terms of work ethic, which is one of the things that I think a lot of people are concerned about, I was picking that as an example because I think when people are really motivated and really believe in themselves and really believe that what they're doing is something that can change the world, they'll work incredibly hard and be passionate just because they believe that. But if they just believe they're doing routine, unimportant work, I mean, why would they ever work hard?
Fair enough. So you talked earlier with great affection for MIT, and I guess our hopes of recruiting you are diminishing. But putting that aside, what do you've been at MIT for what, 30 some odd years now?
Yeah, I've been on the faculty since 1977. I was a grad student there, and then I was a postdoc at Harvard. Yeah.
Okay, so I mean, what do you think MIT does uniquely or at least well that has contributed to your success?
Well, I think a couple things. First, MIT gets great students. They have, they do, I think MIT is, in my opinion, the best engineering school in the world. And I think the engineering culture of MIT is very conducive to doing the kinds of things that I do. In other words, I think that an engineering culture helps create an entrepreneurial attitude. But I also feel MIT's had great science, and I feel like that's contributed to what we do. I feel it certainly has not hindered me, the fact that MIT is also fairly porous, that you can cross barriers from different departments pretty easily. And I also finally feel that what's been good for me as doing biomedical research is that MIT is, 10 minutes away from Harvard Med School, which is probably the top medical school in the world. So that,
I've heard of it.
Yeah, no, me too. So I think all those things have helped.
So-
And tied to that is, because they're top, it's like then you get these great fellows from the medical school that come over and work with you, and you have collaborations, and people, come to you with big ideas from the medical school as well.
So I want to double click on two of the things you talked about. You said great students in engineering culture. So what is a great student to you, or what do you look for? And I've read you get something like thousands of applications for a dozen spots or something like that.
Yeah.
So what are you looking for? What makes a great student in that context is one, and explain what you mean by an engineering culture, and I'll
Sure.
remind you if you only get one of those.
Yeah, no, thanks. Well, let me do the second first. That way, I'll remember. So an engineering culture, and I haven't totally thought this through, but when I look at really successful communities that have done well in terms of entrepreneurship, to me, the two that stand out are the MIT Kendall Square area, which is the highest concentration of biotech companies in the world, and then the Stanford Palo Alto Silicon Valley area. And really, if you look at those two schools, you almost always are ranked, 1 and 2, MIT first in terms of engineering. And engineers, you asked a question earlier, which I think was a good question about sort of the purity of science versus, maybe entrepreneurship. I mean, engineers, that's not a big issue to engineers. Engineers, it's part and parcel of what we do. It's like actually almost a good thing. It's not controversial to want to take your ideas and make products out of them. In fact, that's part of maybe the definition of engineering. So I think that when you have a really strong engineering culture and you have quite a few good engineers, then having these spin-outs, it's just a more natural thing. And it's celebrated. MIT celebrates engineering. Stanford celebrates engineering. And they celebrate doing these things. So I think it's all part of it. So there's the possible, because embedded in your question before, and I thought it was a very good question, I've gotten it other times too, is the fact that sometimes there's this tension between pure research and product development. But
Is that the analysis synthesis difference? Is that
I
kind of what you mean?
don't think it's that as much as that a lot of basic researchers, I think, this is just my personal feeling. Certainly I watched this in the 70s and 80s and 90s. I think it's less true today. But I think a lot of basic researchers feel that doing product development, things that are not pure science, aren't so good. It's something to almost look down upon. And it's just not just pure work. It's not like discovering the structure of DNA or things like that. So I think it's more that kind of attitude. And for engineers, if you're making a product, that's a good thing. So I think that's part of the second question. I think the first question, for me, I'm looking for people who are students and postdocs who are, it's going to sound maybe obvious, but, brilliant, hardworking, but a couple other things. One, I really want people to be good people, nice people, get along well with others. That means a lot, especially if you're working in a big lab and you're trying to get people to work together. And I just want that kind of person anyhow. And then I think the second thing is people who want to make a difference in the world, because I think that they'll thrive more in the environment that we have. And that means not necessarily people who are just curious. I mean, but the people who, because somebody who's curious might be a great scientist. But I think the people who have all that and, really want to make a difference, I think that they'll do even more, and they'll fit in well with what we do.
So how do you test for that?
I think you get a sense from talking to them, and then if it's a postdoc, I usually get a sense from talking to their advisors. I put enormous weight on what advisors say, particularly if I know them, because they've seen the student for 4 years, and I've seen them for an hour, a half hour. So I put a lot of weight on what the advisor says.
As we were talking about earlier, we have a new president here, Andy Hamilton, who's a chemist, as you know. And I understand that you may not know or be intimate with the environment here at NYU, but if you had some advice for Andy and this room about what NYU could or should do to foster a more entrepreneurial culture or engineering culture, almost as you put it, among our faculty and researchers, what might that advice be?
Yeah, well, I don't want to be presumptuous because I probably should know more about NYU. But I mean, one is I still think the number one thing is raising enough money so that you can hire the best people in the world in engineering, but in other areas too. I mean, I think quality of the faculty, and maybe it's bringing in money so you can hire some super chairs, and get people to bring in other people. I think that's probably the number one thing. But I think, and if engineering isn't as strong as it should be, and I don't know enough about that, then you might want to make an emphasis in certain areas. I mean, you want to, I think, pick those areas where you feel the future is going to be in terms of those hires. But I think beyond that, I probably would put money into things like entrepreneurship. I mean, and really have a focus on that, which it seems like is being done from just the little I've seen so far. But again, the more one can do with that, the better. Like at MIT, we have quite a few people working in our tech transfer office, and I still think that we're understaffed. And so I don't know what
yours is, I think, an order of magnitude bigger than ours.
But that's an example of having really good people in that office who and having enough of them to serve the faculty.
Actually, ours is headed by an MIT alum, I'm happy to say.
Oh, that's good. But but I think that's an important thing. I think celebrating entrepreneurship at different levels, like MIT also has these 100K competitions, which have been very successful. I mean, those are student-run competitions, but I mean, they have hundreds of teams presenting, and some of them have led to some very, very good companies. I think everything, the MIT has an industrial liaison program, with lots of companies getting involved. But I think helping, and again, these are all things that people they don't have to use them, but if the faculty want to avail themselves of them, they can. I think the space that you showed me across the street, I mean, that's
the Leslie Lab?
Yeah, I think that's terrific. So I think the more of these things that are there, the better. I still think the number one thing is making sure that you have the best possible faculty you can have, but I think all these other things can help, and a lot of them are cheaper.
I want to get to some audience questions in a second, so start to think about those. But a couple of final questions before we open it up is, what are some of the most common mistakes you've seen other faculty, your colleagues, either at MIT or other institutions, make in whether it's trying to be more like you, commercialize their research, having an impact?
Yeah.
What are the kind of the pitfalls that you've seen?
I think the number one pitfall that I've watched is starting a company too early. Again, this is particularly important in the medical area, because sometimes people get so enamored of starting a company, they start it too early. And if you start it too early,
so what is
starting too early goes back to those like 5 or 6 criteria that I mentioned. Let's say you don't have a paper, you just have an idea. Well, if you have an idea, I think in the medical area, I think it's going to be very hard to raise money. And even if you were fortunate enough to get it, I think you're going to run into problems later, because the runway from the idea to a product is just so long. so, so I think that, but that's usually the number one problem is starting something too early. And what I was going to say is that first, it'll be hard to raise money. Secondly, even if you do raise it, you're going to have to keep raising it and raising it and raising it, and you do anyhow with a lot of these companies. But then the runway is really long, and investors often get tired and frustrated. 10 years later, there's no return. 15 years later, there's no return. So that's usually the biggest problem is starting it too early, maybe not meeting those 6 criteria that I mentioned, not having the good patents, not having the good papers, not having the good animal data. But that would just be my feeling.
So actually, I want to go back to that list of 5 things and talk for a brief moment about the notion of platform technologies. So one of the, so I'm a venture capital investor in addition to running our entrepreneurship programs here. And one of the challenges that I see with platform technologies, while the potential is greater, and I think that's kind of implicit in the attraction there, I often have a hard time helping those pursuing those to see that you need to have a first.
Oh.
So can you talk to that?
Yeah, well, that's a great point, and we touched on that a little bit before, but not in such an explicit way. When I was saying that, to me, what we do in academia is sort of the basic work, creating that platform. But what you just said is so important when you're now moving from the academic place to the company place, because especially in medicine, you don't get a lot of shots on goals. Medicine's so expensive. So what you need is a really well thought out first shot, second shot, and so forth. So it's really figuring out let's say somebody now, and we're seeing this, you can do gene editing for the first time, or you can do mRNA, to create new gene therapies. What should be the right applications for those first, second, and third? And that, like I say, is to me a combination of not just the academic scientists, it's business people, and if you don't get it right the first time, it's a big cost, because you'll be burning through so much money, and you won't have that much for the next time. And a lot of times the public or whoever's investing can be naive, and they'll say, well, the technology doesn't work. That's not necessarily true, but people get tired. Like you take monoclonal antibodies. When that started in the 70s, that looked like it was going to be a revolution. But for probably 20 years, monoclonal antibodies didn't work. And now, of course, half the top 10 best-selling drugs are monoclonal antibodies. But it took a long time. So figuring out, the right things early on is key.
All right, let's open it up to the audience. There's a gentleman walking around with a microphone. If you have a question, actually, there's a gentleman right there. Why don't we go to him first, and then we'll bring it around to you. Andrew, can you grab the microphone?
First, I wanted to thank you both for a great discussion. And my question has to do a little bit with chicken and egg. How often do you start noticing a discovery and thinking there's something I can do with it, or how often are you looking for a problem, something you can do better, and try and work backwards from there?
Well, I think both. I've seen both happen. I mean, sometimes it's like we come up with an idea, like I mentioned, like a gene therapy approach or a drug delivery approach, and then trying to think what you can do with it. But other times I've had clinicians come to me or foundations come to me, and then I work backwards. Like an example we just published this week is the Juvenile Diabetes Foundation came to me about 8 years ago asking about ways of encapsulating islet cells, which could maybe lead to new treatment for diabetes. And, with one of my postdocs now, he's a professor, Dan Anderson, we spent 8 years on this. We just published earlier this week a couple papers in Nature Medicine and Nature Biotech showing that we could create materials now that hopefully can solve that. And we'll start a company on that too now after the 8 years. But the thing is that both those things have happened. And I think it might almost be 50-50. It's hard for me to pick numbers, but I think both have been fine, and we do both.
A question right here? Here, grab the mic, please.
Hi. So one thing that's a little strange about New York as a place for biotech is there's a ton of really, really good research, but not that many startups, particularly in comparison to Cambridge. So, and I think part of the reason for that is New York is still a city that really values finance, law, and technology, and less so biomedicine. And that's been part of the city's culture for a very long time. So my questions are, do you think New York will ever be a place on par with Cambridge or Palo Alto in terms of biotech entrepreneurship? And also B, how do you raise the profile so that people in New York start to care more about biotech and biomedicine, and so that it's just as easy to raise funding to screen a molecule as it is for, you know, an internet advertising startup?
Yeah, well, those are great questions, and I guess what I'd say is the following. I mean, New York, I mean, it's such a great city with so much money and so much talent. I mean, I think it certainly puts its mind to it in a collective way. One would like to think it could do just about anything. But so what does it have to do? I mean, to me, it's making the great University of New York, and there are a number of them, even greater. I mean, it could have to do with money. It could have to do with other incentives. But I mean, I think that's one thing. You know, that you know, would be helpful to be done. But I just think that's, you know, the more New York values, I mean, this is going to maybe sound self-serving, but not to necessarily this audience, but you know, to me, the more that New York values academia in general, I mean, which Boston does, you know, I think things flow out from there in the beginning, and then things, you know, get a force of their own. So I think the more that can happen, the better. And that sort of leads a little bit to your other question, what can be done? I mean, I think that really does come from the government officials. You know, my personal feeling was Mayor Bloomberg. I mean, again, I'm an outsider on this, but I thought his idea of having, you know, what now is the tech campus at Roosevelt Island, I think things like that really wouldn't have come about without his initiative. You know, to me, that's visionary leadership on the part of a New York mayor. Even Cuomo's idea of tax-free New York in certain areas. I think these kinds of things, you know, are really, really important. But I think the more the state and the city create visibility, show the nation, show the citizens just how valuable these things are, that those will help raise the profile. But I mean, it's a long process. These things take a long time. I'll just tell another little story, which I think might be instructive along those lines. You know, in a couple ways, because change can happen even if people think it can't. You know, so in 1956, the provost at Stanford, Terman, who was an engineer, he talked to William Shockley, who was winning the Nobel Prize, got him to come out to Palo Alto because he gave him some land to start what was going to be Shockley Semiconductor. And Shockley, then he called a young guy up, Robert Noyce. Robert Noyce was an MIT graduate, and in the 1950s, his first company that he worked for was Philco, which was a television company in Philadelphia. And so he went out there in 1956 for an interview, and he came back to Palo Alto. And he went back and told his wife, he said, I think I should take this job. He said, the housing out here in Palo Alto, it's a lot cheaper. But the point is it can happen. And, you know, you can do those kinds of things. And when value is created in those ways, I think other things follow.
I mean, for the record, it's still happening in Palo Alto, even though
Yes,
it's not far cheaper.
that's correct. But that's actually my point, that once something gets on a roll, it gets a life of its own. I think what's happening in Boston now and what's happened in Palo Alto, you don't have to work that hard at it. You know, what'll happen is the people who are at
You don't mean the entrepreneurs don't have to work that hard at it.
well, what I mean is it gets a life of its own, right? In other words, you don't need to, what I mean is you won't need the Bloombergs or the Termans to jumpstart it. You know, and what'll happen is that the people who worked at Hewlett-Packard, some of them will leave and start Apple. And some of them will leave and start something else. And the same thing in Boston. Some of the people at Biogen or other companies will leave and start. So it gets this momentum of entrepreneurship, and it feeds on itself. But I do think your question's great, because my feeling when I look at New York, which is, you know, the biggest and greatest and most wealthy city in the United States, I mean, could do better. And I think, so that's why your question is so important. But what it's going to take is the right leadership at a government level. And like I say, I applaud what Bloomberg did. I think that was a tremendous thing in the right direction. But there can be more.
Another question.
I'm curious, in the process of the 5 or 6 steps you mentioned to validate before you spin something out, in most academic institutions here in New York area, we're not GLP compliant. So when you mention the studies in animals, have you found that to be a problem, or at what point do you consider outsourcing if it's needed?
Yeah. I don't think the GLP issue for getting the investment is essential. It'd be great if you had it, but really what people will do, whether it's a venture capitalist or a company, is they'll look at why something won't work, right? Are there some hurdles that are so difficult scientifically that it won't work? Like, will the drug be toxic? I'm making this up, or will it kill something? But I don't think the GLP thing, I mean, that's a monetary thing. In other words, people will know if they put money in, that can be a solved problem. But it's usually, again, if we're talking about the medical area, a biological obstacle that people are going to be most worried about. And so if somebody hasn't done something in an animal, they'll certainly worry about it, and they should. And if they haven't done it in a right animal model, then they may be worried about it. So I don't think the GLP issue is a deal breaker.
There's actually a question right behind. There you go.
So for us, not experienced in nurturing students for entrepreneurship, and also you hear your colleague always say, okay, those students, they're struggling to get a PhD. So how do you nurture the students, in those ways to help them,
Well, I mean, by the way, I guess I still think getting the PhD is the first thing you want to do. I wouldn't want to give that up. I think that's very important that they get it. I think all you do is have activities, this being a terrific example, and in the shop across the street, and there are other things that may be done that give students exposure and opportunity so that they want it, that they can avail themselves. But I would never want somebody to not get their PhD. But I think just having an environment where students want to be an entrepreneur or want to be exposed to that, they can be. And that there are places, whether it's the center, the people, what was it? Leslie, yeah, that, or whether it's, great tech transfer office. But to me, the university can do a number of things that can create opportunities for students if they want them.
Are there certain things as a PI that he could potentially do, or do better, or do differently that to facilitate that more?
I don't know that you need to do that much. I mean, my feeling is that if there are activities going on campus, I would let the students know. And I think the campus itself can have those kinds of activities, whether it's what we're doing this morning or other things. But like I say, I do think, as an example, and I don't know if they have something like this here, but like one thing I think has been great at MIT is this 100K competition. Very inexpensive. I mean, it costs $100,000. Used to be $50K, and I don't even know if it matters. But that's like MIT's sport, right? I mean, they'll have 200 teams and they compete, and
we have a 75K.
But that's great. But what you could do, but that's exactly so then you could say, it could be like an email that goes out to the lab, saying here's the 75K thing, and like at MIT, a lot of times it's scientists or engineers teaming up with business people, it could be, creating an opportunity where they could, meet each other and stuff like that. But I think just letting students know that there's these opportunities.
So encouraging them, it sounds like, is kind of what you're saying. Encouraging them to take advantage of the
If
opportunities and resources if they want to.
If they want. That's what you said is exactly right. If they want to. I would never want anybody to, a lot of people may not want to do entrepreneurships, and they shouldn't. But if they do, then just creating these opportunities, like you said, I think, and 75, that's great.
Yeah. Win?
Hi, Win Burleson, College of Nursing here at NYU.
two or three facets to this question. The question has to do with the nature of the university and the opportunities for faculty members to advance the kinds of institutions that you've created. What do you think the university's, you've talked to a couple of different things like the entrepreneurship and the oil or the IP offices, but is there something more fundamental in terms of the way the tenure track process works for faculty, where you have to go get a federal grant that only allows you to do these things? This kind of tension between the open entrepreneurship and this. Possibly a second facet to this has to do with the opening of universities and the open courseware initiatives and whether that's going to have a big role. And then a third piece has to do with open competitions and your thoughts on these large-scale like Google X or DARPA challenges, if that plays any role. So a couple different things to think about there, but just a question.
Yeah, boy, I'm not sure how to answer. I mean, I think all those things you said at the end are good. I mean, I'm all for things that give faculty and students money and those kinds of competitions and things that make people think out of the box. But there may have been another part of what you asked, and I'm not sure I necessarily captured this, but which I think is complex. In other words, and that would be, should promotions and things like that, should entrepreneurship play a role in that? And that's complicated because I do feel that if you're a scientist or an engineer, that you have to be judged on either the science you've done or the technology you've created, and not how good a salesperson you are. And part of being an entrepreneur is actually being a good salesperson to an extent.
You don't think that comes into tenure too, though?
It does, but it's but it's a different kind of thing. In other words, if you, I'm trying to think how to say it, but it's like I could see somebody that could be just a tremendous entrepreneur selling something unimportant, and so I guess it's you'd have to obviously figure out how to draw the line on those things. I mean, obviously raising money, everything we do as an academician, there's some sales involved, but to me it's not quite the same thing. Like I wouldn't want to have somebody that was selling, I'm trying to remember all the old ads where they're banging plates together and stuff like that, and so I think it depends on what it is that you're doing, and I think it probably ought to have some academic component in the area, and you have many different schools here, in the area that you should probably be really good at whatever it is that the school values.
Up here?
Dr. Langer, just phenomenal. Frank, thank you for putting this together. My name is Paresh Shah. I'm one of the chairs in the School of Medicine. And before I ask my question, I want to just take an opportunity to plug a little bit for NYU, because NYU is actually doing a lot of the things that you've mentioned. Frank mentioned the 75K. We had our first healthcare innovation makeathon this past year, designed to bring together engineering, medicine, nursing, STERN, business, all together in a forum, solving problems from a very problem-focused direction, encouraging entrepreneurship and trying to create that culture of entrepreneurial activity in the context of science and healthcare. But you're right, it's a self-selection criteria. You've got to have people that want to do it and that are motivated to do it, to pursue it, because if you don't want to, you won't do it well. And I apologize for editorializing.
No,
on
I'm
that,
actually glad you said that, and I'm delighted to hear that you have these programs. I think those programs are great.
I think they are exciting, and to the person who commented about New York, the financial sector carries billions of dollars, but that doesn't mean that there isn't a lot of resource dedicated to biomedical and healthcare innovation. There really is, and it is here and it is growing. So I wouldn't be discouraged by geography. I think there's plenty of opportunity there. My question for you is a little bit different. You've had a phenomenal track record and success, both in science and in entrepreneurship. But some of the most valuable lessons that we can learn as attempting entrepreneurs are from our own failures and from those of others. Could you speak to lessons that you've learned from unsuccessful translation to commercialization, if you've had any?
Oh, sure.
And what some of the challenges that you faced in that context were? And the follow-up to that is, what do you see evolving in the landscape around biotech that will create new challenges for the current crop of entrepreneurs coming through?
Sure. Well, great questions. And let me, to me, when people ask me, and I'm glad you actually asked that, because when people ask me what is the number one reason why a company succeeds or fails that I've been involved in, and I even would put it on a degree, is I always say, I'd like to tell you that it's how good the science is. But really, and it relates to something we were just talking about, to a certain extent, what my answer is really, it relates to how good the CEO is. I mean, the number one criteria for me, in terms of how successful companies have really been how good the CEO is. Probably number two is how good the investors are. You know, I mean, obviously the science will play a critical role, but when I look back at the companies that haven't done as well, our CEOs haven't been as good. And when I look back at the companies that do incredibly well, it's because the CEOs have been spectacular. That then gets into the second issue, both now and in the past, about what makes them good. And really, again, in the medical area, but this may be true in other areas too, is the number one thing that a CEO has to do is raise a lot of money. And yet you have to raise a lot of money with the idea that you're going to keep raising a lot of money and keep raising a lot of money. So if you overpromise, that's not good. I mean, if you're just a salesperson saying, well, this is great, you know, and people put in money the first time, well, that'll get you the first round, but that won't get you very far. So you really have to deliver on the science, and you have to be very credible at painting the picture so that you're going to raise money from investors, from other companies, and so forth. And the reason that's so important is that it's so easy to fail in medicine. And by the way, it's easy to fail in other areas too. But the thing is that with medicine, we talked about this a little bit before, you don't have that many shots on goal. But the more money you raise, the more shots on goal you'll have. And that also, I think, relates to the last part that you asked about people for the future. Sadly, again, if we pick the medical area, it's going to cost even more in the future. Whatever anybody wants to say about price controls and stuff like that, it's going to cost more and more, so that these issues aren't going to go away. And the people of the future, you know, the threat of, what should I say, government control or other kinds of things, I mean, those will end up being a real impediment to, you know, not that there's not some serious reasons about, you know, the concern about prices, I mean, but nonetheless, I mean, it does take so much money, and I don't think the public necessarily realizes how much money it takes to create a new drug or a new life-saving treatment. So I think it's going to be not only educating, you know, the investors, but educating the public, you know, about these kinds of things. And then sometimes the government you have to educate, like the patent laws were changed a couple years ago, and now you have like hedge fund managers, you know, challenging patents very easily, and those patents can be key for those companies. And yet it wouldn't have happened. I mean, the government passed the law trying to help the internet companies, but by doing so, hurt the medical companies. And these things are complicated, even the tax clauses on medical device companies. So, I mean, there's so many things that a person has to be thinking about, both with their own company, but also more globally when you think about these things. So you asked, there's a lot of things embedded in what you asked, but those are some of the things that I think about.
So, actually, question right here. Then we'll go back there.
Thanks. Before you even have a startup, you have so many of these products you've created that have been successful, but that means you must have had a high failure rate with all these projects that have been started in the lab. So what is your failure rate or dead-end projects?
Yeah, you know, it's so you have to. I don't have specific numbers. I mean, part of the reason, I guess I break things down into two categories. So first, academics. When we do something academically, I mean, I think first you'd have to define failure. You know, like the way I think about it is, if we've published a good paper and students had a good experience, that's not a failure, that's a success.
But you have projects presumably that don't even lead to a paper, right? I mean, it sounds like you give people really a lot of leeway to try new things.
Yeah, But most things do, you know, when you try to help somebody craft a thesis, you, at least I do, and I think most people do, set it up in a way so that they almost assuredly will have a paper. So I would say that the failure rate on that criteria is very, very low. I mean, it'd probably be, I mean, it's hard for me to think of any student, you know, maybe it's 1%, you know, that hasn't graduated, that hasn't gotten a paper once they've started. But that may not be what you're asking. In others, so then if you go to the company explores all kinds of things. I mean, I don't, again, have an exact failure rate, but I mean, it would be much higher because there you're trying to create products. Some of the products, you know, you get data in animals and you say, well, it's not worth going into phase 1 trial, or you go into phase 1 trial and maybe there's some safety issues and so forth. So there, I'm sure the failure rate is much higher.
But I guess what my question is also that one of your criteria, which you didn't list, is probably that you have to not be risk averse.
Sure.
Right?
Well, yeah, that's though, I agree with that. I guess there's a lot of criteria I probably didn't list that I guess I felt the 5 or 6 criteria that I put in, you know, were, I don't want to say unique to me, but those are ones I thought through. I think if you're not risk averse, you should never get involved in a company in the first place, a startup. I mean, so I took that for granted. And you're probably right to tell me that it was worth mentioning, but I just...
Academia, you have to mention it nowadays.
Yeah, but I certainly tell my students when they go into faculty positions too, as well as companies, you know, to me, taking a risk, that's important because then you have a chance for a big reward.
While we're getting to there's a lady over here with a question. So Edison has a quote that I like, and I want to know if it's something that you relate to. He goes, I haven't failed, I just found 10,000 ways that it doesn't work.
Yeah. Well, I've said things like that too. I actually, when I did some of the controlled release, I don't know if I found 10,000, but I find a lot. And I think that's right. I think that when you do these things, and that's why you need a definition of what failure is and what success is. I mean, you know, because depending how you define it, you could fail all over the place or you could succeed all over the place. I mean, but a lot of times when we do research, I mean, I look back at what we did, and if I knew at the end what I knew if I knew in the beginning what I knew at the end, I mean, I would have saved myself years.
My question is, thank you very much for this super talk, but my question regards the size of the lab. Is it necessary to have a huge lab like yours to be successful, or could you also start startups from a small lab?
It's not, I don't think it's necessary to have a big lab like ours to do this. In fact, our lab wasn't nearly as big many years ago. I mean, the reason our lab got bigger is just, is that people gave us money to do things that I felt were important, and I wasn't going to turn it down. But I don't think it needs to be that big. I think that being said, the fact that it is big, I suppose more things go on that could lead to startups, but it certainly is not necessary by any means.
Probably have time for maybe one more question. Is a question in the way back there? You raise your hand.
Hi, thank you, Dr. Langer. I'm a postdoc. My name is Tom Coughlin, and I am in my first year. And a lot of what I hear as I've gone into this postdoc has been there's a huge postdoc problem. There's a huge academic problem. There's a huge problem with funding. But I hear like a lot of successes as well. And so I think a lot of time I find myself sifting through a lot of the negativity to find the positivity in finding how to succeed. And I hear from your lab that it's a cultivation and it's an environment where people are succeeding. And so how would you say that for someone like me trying to break into the field, what advice would you have to sort of perhaps not try to duplicate what you had, but in the reality of the situations where funding is being cut and not that great, how would you say someone like me can start, and start small?
As a faculty member, you mean, or
As a faculty and as a postdoc, and how to combat the postdoc problem, and maybe you can address the current field of postdocs and how the academic world could be changing as a paradigm shift towards cultivating perhaps team PhDs, postdocs, and then also just how to duplicate, in some sense, what you found.
Yeah. Well, I may not fully understand the question, but let me try.
Thanks.
My advice when people are postdocs, probably graduate students too, but I still believe that the number one thing that is worth doing is trying to publish papers in the very top journals, which also actually involves some risk, both in terms of choosing the project and even trying for those journals. Like, you know, it doesn't make me particularly happy if Science or Nature turns me down, but I'm going to try for top journals, you know, most of the time if I think the paper merits it. And I'm also going to try for projects that I think have big impact. So the first message I guess I would give is I do think it's worth taking a high risk as a postdoc to try to get seminal papers and to try to get them in the top journals. I think in terms of the second point, raising money, you know, and that may be later on as a faculty member or even as an entrepreneur, but I'll particularly pick faculty member, is I always break it down to two things. One, finding out where money is, and two, then getting it. And they're not necessarily, so I remember.
Follow the money.
Yes, but it's interesting. Like, I helped start this school when I was a graduate student for poor kids, and it was amazing. And I got involved in some of the fundraising too, but the people there were very smart. You know, we found money in places that it was like a private school for poor kids. You know, places that you might never have thought. Like, they wrote to the National Institute of Drug Abuse saying that. Got a big grant saying, look, this is actually true. 35% of the kids in Cambridge then dropped out of high school. They had drug problems. And we said, well, if we create the school, they'll be in the school, they'll have fewer drug problems. And the school got a lot of money from, you know, National Institute of Drug Abuse. And over again, you know, we found different pots of money that you might not have thought were the case. And I think that that's true today, too. You know, there are all kinds of foundations. There's other governments. I mean, MIT is great at, you know, MIT get money from Singapore, from Russia, from, I mean, God knows where, you know, and from companies. So there's lots of places to get money. Those places have different rules, though. If I'm going to get money from the government, I've got to, you know, they might have a study section, they might have certain goals. If I'm getting money for a foundation, they probably want a disease cured. And you have to tell your proposal and what you say to them. If I'm getting money from a foreign government, I mean, they might have a particular set of things that they're interested. If I'm getting money from a company, maybe it's a patent that I have that they're going to want. So I think it's like both those things. First, figuring out where the money is. And the money, to your point, actually, one of the smartest things you can do is look in places that nobody else looks. And if you're able to figure those out, that will help you a lot. And then the second thing is understanding the ground rules for whatever it is, that organization that's going to give you the money. And it's very different. You know, if you're writing an NIH grant, probably it's good if you've solved the problem so you can show, you know, that every single thing you propose, you know, there's probably a likely solution. Whereas if you're trying to cure a disease, you know, somebody might say, well, this is a breakthrough idea, I'm willing to take a risk, and if you can treat diabetes or something else.
All right, so I think
you.
with that, we're out of time. This has been incredibly enlightening, enjoyable, and fun. And so let's give Bob a big round of applause.
Thank you. Me too. Great job. Great
Thank you.
questions.
Thank you.
Well, thank you.